In this video, we will look at how to determine the project schedule. We would start by finding the expected time based on various estimates here. We have optimistic, likely, most likely, and pessimistic estimates. Based on these, we will find the expected time and the task variance, and then we would calculate the critical path using AON network diagram. And then finally, we would answer this question: what is the probability of completing a project on or before 32 weeks, which is the due date for this project. So we'll start by calculating the expected time. So expected time is calculated using this formula here, which is optimistic time plus 4 times likely time and plus pessimistic time, and the whole thing divided by 6. So we'll write a formula to do this. So we start with the equal sign, optimistic time. And before putting equal sign, let me start with the parenthesis. Optimistic time plus 4 times most likely time plus pessimistic time divided by 6. That would give us the expected time for the task. So that's 5, and I'm going to fill the rest. I'm just going to round it off to a whole number. So we have these as the expected time, and then the variance is calculated using this formula here. So let's type in the formula: pessimistic time minus optimistic time, and the whole thing divide by 6, and then we're going to raise that result by 2 to the power of 2. So we're going to use the hat sign here to raise to the power of 2, and that gives us variance for that task. And I'm going to round it off to around 2 decimal places. And next, before you go and calculate the project variance or the expected completion time, you have to find the critical path. So to find the critical path, we can use this AON network, which I have already drawn based on the information given here, task name and predecessor. Now we'll need to fill this up. So I'm going to quickly fill up the durations here. So A duration is expected time here 5, B is 5, and then C is 6, D expected duration is 13, and E is 6, F is 4, G is 9, and H is 2. Now once you have the durations, we can quickly do a forward pass to find the early start time and early finish time. We have the duration here, early start time and early finish time. We can find out using the forward pass. So we start by 0 here is the first task. 0 plus 5 is 5. And we can transfer this early finish time of the predecessor as the early start time. So it's 5. 5 plus 5 is 10. And this again is 5. 5 plus 6 is 11. And now you have a task D, which is dependent on B and C. Now in this case, you would select the maximum of these two, which is 11. And then you do the calculation. So that is 11 plus 13 is 24. Now this is dependent on only D, so you can just put 24 there. And E is dependent on B, so 10. And G is dependent on C, so it's 11. And then you can find 11 plus 9 is 20. And that is 28. And that's going to be 16. And now you have to find the early start time of E, F, and G. Now, again, it's edge dependent on E, F, and G. So you take the maximum out of these three. So the maximum is 28. So that's going to be 28 plus 2, 30. So that's the end of forward pass. We have found the total duration of the project, which is 30 weeks. Now, to find the critical path, you need to do a backward pass. So to do the backward pass, you just transfer the early finish time of the last task to the late finish time. So that's going to be 30. And then you work backwards. 30 minus the duration is going to be 28. So the slack, which is this one, is the difference between early start and late start, or early finish and late finish. So that's going to be 0. And here it's 28. 28 here as well. And 28 here. Because all of these tasks needs to finish by 28th week for this to start on schedule. So then you work backwards. So 28 minus 4 is 24. And the slack is 0. And 28 minus 6 is 22. Slack is 12. And here 28 minus 9 is 19. So slack there is 8. And then this task is going to be 24 minus 13, 11. Again, no slack. So again, this task is also in critical path. So all the tasks which has slack of 0 is on critical path. And then now for this task C, this is a predecessor of D and G. So when you're working backwards, you select the minimum, right? So here, because you had to finish C for that, so that this can start on time. You had to finish C on time so that this can start on time. So you had to put 11, not 19. So 11 minus 6 is 5. So no slack there. And for this one, so again, 11 and 22. So you take the minimum. So 11 minus 5 is 6. Slack is 1. And again, you take the minimum. So that's 5. Minus 5 is 0. Slack is 0. So all of these tasks that has a 0 slack, this one, and this one, this one, this one, and this one are in a critical path. I'm just going to quickly highlight that to show the critical path. So a critical path here is A, C, D, F, and H. That's how we find the critical path. So that is A, C, D, and F, and H. Highlight that. Now to calculate the expected completion date, you just simply, we already done that, that's 30. So you can also do that from here. So that's going to be the expected time of task A plus expected time of task C, task D, task F, and task H. So again, it's 30. So the variance, that is the total project variance, is the sum of variances of all the critical tasks. So we can get that from this column here. So variance of task A, task C, task D, task F, and task H. So it's around 7.72, and from this we can find the standard deviation for the entire project. So that is equal to square root. So we can use a quick function here, square root of project variance. So that gives you 2.78. And to answer this question here, what is the probability of completing the project on or before week 32, assuming that the project duration follows a normal curve. We can use this formula here to first find the z-value and then look up the normal curve table to identify the probability. Now, this z is calculated by deducting expected completion time from due date, divide that by standard deviation. So to do a quick formula here, so open bracket, due date is 32 minus expected completion time is 30. The whole thing divided by standard deviation. So that gives you the z value of 0.72. And once you have this, you can quickly tell the probability of completing the project on or before week 32 by finding the norm using the normal distribution table. So I'm going to use a formula to do that. You can use the lookup in a normal distribution table as well. So the formula that you can use on Excel is norms distribution, and that just takes the z value, which is right over here, and then that'll give you 76% chance of completing the project on or before week 32. All right, so that wraps up this video. I'll see you soon in another video.